Okay, so we're losing fluid, but I think you can see that always the deepest one had the highest velocity and the highest pressure.
नहीं वो डाउन करने में शायद दिक्कत हो रही है। बबलिंग हो रहा था शायद लास्ट में,
तो उसमें तो एक सब्सटेंट ही नहीं दिखा ब्रास वाला जो होना चाहिए। क्या हो रहा
is used to generate huge force by applying much smaller force in many heavy vehicles like bulldozers, trucks, etc. Hydraulic brake is used in heavy vehicles. Hydraulic lifts is used to lift heavy objects. So we see a simple rule can have such huge application.
You've heard of a 7-layer burrito, right? So this is a 7-layer liquid. So this is rubbing alcohol, and I just colored it green. So I just a little green food coloring, and so hopefully this will go on top. And again, it's just a slow little squeeze on top so that we can get that next layer.
So you're not getting it, so it's not penetrating, right?
You're trying not to get it down there, yeah. And we're doing it really, really fast, and I'm happy with the results, even with as fast as it is. But that's 6 layers on top of that. The very last layer is the layer that is the one that's not necessarily a household item. The last layer is going to be lamp oil.
Is
so
it
if you
problematic because is it tricky to get the last one in there?
No, it's not tricky. It's just, not material that you want the kids just playing with. So
Okay,
that's one of
lamp
those
oil,
things
right,
that Mom
yeah.
and Dad are going to
Right.
squeeze onto the very
Look
last
at
one.
that.
Is that
How
cool?
cool
That's
is
6,
that?
and finally here comes number 7. And so here's our lamp oil there.
This is a great science experiment,
Isn't that a fun
particularly
one?
with all that's going on, in the ocean. With
Well, you know what? We've done our oil polymer a number of times, and we actually featured that on the morning show. And all the scientists are saying that while those polymers are out there to help encapsulate the oil, the real problem with it is the spill is so big that they literally have to put that polymer in a boom and be able to put that on the shoreline and kind of hope that they can kind of get it in there.
I think we have to send you out there to the shoreline.
No, are you
there and
kidding?
see if we can't get that fixed.
Those people have got that under control, and they're really looking at the containment. So you can imagine the brightest minds are out there trying to figure it out. But I think that's a good one.
There you
Watch
go.
this. Here's a little bit of this behind there, so you can see. And we did.
Have you ever noticed that oil floats on top of water? It has to do with how water molecules interact with the oil molecules. Oil is insoluble in water. That means it doesn't dissolve in water. The way in which two substances interact depends on the molecules that make up the substances. When oil is poured into a glass of water, the water molecules and the oil molecules meet for the first time. As they are stirred together, the water molecules and oil molecules move around each other. When the stirring stops, the oil and water immediately begin to separate. This is because the oil molecules are not attracted to water molecules. They are more attracted to other oil molecules, and so the oil molecules clump together. At the same time, the water molecules also clump together. Water molecules are more attracted to each other than they are to the oil molecules. As the oil molecules and water molecules clump together, they separate. This is because oil is less dense than water. The oil molecules rise above and float on the water molecules. That is why oil and water do
Potato tied with thread, water jug, overflow vessel, beaker, and a beam balance. Fill the overflow vessel with water. Empty the water from the beaker under the overflow pipe. Place it back under the overflow pipe again. Take the spring balance and measure the weight of the potato in the air. It weighs 125 grams. Now immerse the potato in the overflow vessel completely. Observe the potato, which displaces some water. It overflows and collects into the beaker. The balance shows the weight of the potato in water is 13 grams. It is less by almost 112 grams. Now let us measure the weight of the displaced water. The balance reads 110 grams. It is almost equal to the weight lost by the potato when submerged in water. The 2-gram error is because of water lost while changing containers. This is what the Greek scientist Archimedes meant when he said that when an object is immersed in a fluid, it will seem to lose weight, and this apparent loss of weight will be equal to the weight of the fluid displaced by the object. This principle is popularly called the Archimedes principle. The loss in weight experienced by the potato is because the water exerts an upward force known as upthrust on the potato. The weight loss is only apparent because if you take the object out of the liquid and reweigh it, it is seen to have its original weight.
See,
I don't know, because there's still stuff in it.
Okay, there's stuff in it. Good.
Right, there's still.
Okay, good. Right, nice.
Right.
How about big K? Float or sink?
I'm going to say sink.
Yeah, very good.
Okay.
Now, did you have parents that used to throw the can into the swimming pool as well? And then if we try the Diet Pepsi, well, there must be
Wait
an
a
air
minute.
bubble. That's what it is. There's an air bubble. And oh my gosh. Wait just a second. Kim, out of all these here, which one's going to float, which one's going to sink? There's a Diet Pepsi, there's a sparkling water, and a grape.
Okay.
How amazing is that? Isn't that kind of fun? Now, there's not air bubbles underneath there. It really is floating. And so the general rule here is that everything that's diet will float, everything that's regular will sink.
Sink.